Welcome, ladies and gentlemen, boys and girls. Today I want to solve another cool problem, which is partition list. So basically, this is the best problem. It is a like from my side. Okay, let's see what the question is. The question is saying like we given the head of a linked list and a value x partition it such that all nodes less than x comes before the node greater than or equals to x. Okay, so what is saying like we are given something x. So x can be any value. So it's over here 3. So what we have to do, we have to put less than 3 over here and greater than 3 over here. Okay, so I hope this thing makes some sense to you guys, like what the question is saying. Okay, so let's just look at over here, like how we gonna do this. So I will just take okay, instead of taking to the whiteboard, should I take you to the whiteboard? Yeah, I will take you to the whiteboard. Okay, so let me erase everything from over here, and here we go, ladies and gentlemen. So what I will do, I will just first of all create two dummy node. Okay, dummy list. So I will call it before head and after head. Okay, so before head means like the value less than x will attach on this dummy list. Okay, and initially its value is 0, so I will say its value is 0. And after head means the value greater than or equals to x will come over here on this list. Okay, and then we will join them together. Okay, all right, so let me just take you let me just take that following example. We have something like 1 4 3 2 5 2. We have 1 4 3 2 5 2. So I will draw it over here. We have 1 4 3 2 5 2. Okay, so like this, this. So they're pointing. My mistake, I just drew it very bad. So okay, let me just erase it and I will draw it good for you, only for you guys. So make sure to hit and like this video. I'm just drawing only for you. Here we go, ladies and gentlemen. So okay, I just draw it. So we have something like this. Okay, and we have to put it over here, and our x is 3. Our x is 3. So it means like the value before the 3 will come on the before head. So this before and value after the 3 will come over here. After the 3 or equals to 3 will come over here on the after head. So I will use two pointer before and after. Okay, so I will just call it before and after. So the before pointer will check. So it will check if my head value is less than x. Then what I will do, I will point it over here. I will point to my over here. So in this one is less than 1 is less than 3, so it will come over here. It will come over. Now on this one I will check, is less than 3. It will say no, it's greater than 3. So what will happen, I will use my after pointer and it will come over here on my after head. Okay, similarly on this one I will check, is it greater than 3 or equals to 3. It will say it's equals to 3. So similarly I will attach over here. Now on this one it will check, it is greater than 3 or equals to. It will say neither is greater than neither equals, it is less than 3. So what will happen, I will add to my before head over here. I use using my before pointer. Okay, on in this one I will check, is it less than 3. It will say no, it is greater than 3. So what will happen, I will add it over here on my after head. Now on this one I will check, is it greater than or equals to 3. It will say no, it is neither greater than 3 or neither equals to 3. It is less than 3. So what will happen, I will attach over here. Okay, so we just complete traverse our original linked list. So what will happen, it will my original head will point to the null. Once my original head points to the null, so what I will do, I will say okay, so it means we just done it. Then I will say my after dot next, this is my after pointer, my after dot next points to null. Okay, because now we have to join them together. Now we have to join before head and after head together. Okay, then what I will do, let me zoom it out to get some more extra space. Okay, so now guys, what I will do, I will just simply say, do one thing, attach my before dot next over here. So my before dot next will come like something like 1 2 2, and it will attach this one after the head, after head dot next. Why? Because initially we have 0, so I don't want 0, I want from the 4. So it will come something like 4 3 5 and finally none. So that's our all the list, like partition list, that what the question wants from us. So ladies and gentlemen, I hope like this idea this give you some idea like how we're gonna solve this problem, because this is a very easy question. Believe me, it's very easy code, very easy to do. So let me just move it over there. Okay, so you will definitely gonna understand. Believe me, you will definitely gonna understand. So list node, I will say before head. So I'm creating my dummy list over here. So is the new list node, initially value I will give it 0 because I love to give 0. Okay, and list node before will be our before head. Okay, because it's a pointer, before is a pointer. Okay, and it's pointing to the before head. Okay, it's like initially at over there. Now we create list node after head. My after head is a new list node, initial value 0, and my after is after I will get an after pointer, and after pointer is initially at after head. After is at my after head. Okay, so ladies and gentlemen, I hope this thing makes some sense to you. Okay, so now what I will do, ladies and gentlemen, I will run a while loop. My while loop will run till my head node equals to null, till my head does not reach the null. Once it will, then I will simply stop traversing it. Okay, in this one, what I will do, I will check if my head dot val is less than x. If that's so, then what I will do, I will say before dot next, because I have to point before the using before pointer. So initially I'm at before head is at 0, so I have to point after it. So I will say before dot next equals to my head. I will put my head value over there, and I have to update my before pointer. So now my before pointer will come on my head on. Okay, before equals to before dot next. So I just update over here. Similarly over here, else was the condition if my x is greater than or equals to my head value. So I will attach to my after head. So I will say else what are you have to do, after dot next equals to head, and update your after as per the above which I told you. Similarly, what will happen, initially I'm at dummy one, I will come over on my like it's pointing to the my next one, it pointing to my head. Now I have to update my after pointer. So my after is initially at my dummy, so it will come on my head now. Okay, on the new node. Okay, it will come on the new node, not head, on the new node. After dot next. Okay, ladies and gentlemen, so I also this thing is very clear. Okay, so finally, what last thing we have to do, I have to update my head as well, because every time we have to update. You can either update in the using if loop, but try to make the short as short as possible. So it's very helpful to see. It's a very good thing to do. Okay, and finally after coming out of this loop, what we have to do, I have to simply I have to simply say after dot next, my after value is null. So it means like once I am on the end thing, I will say my just point my after to my null. Okay, so here we go. Now what we have to do, I have to say my before dot next will be my after head dot next. What I'm doing, I'm just joining them together. So after my before dot next, so I'm on the before one, so attach to the next value on my after my before pointer, attach my after head dot next value. Like after head, like what we have over here. If I will take you to my this test case, so it means like we are on the we are on the over here. So I have to attach over here. So I use before dot next. What I have to attach after head value, after this value, because we don't want 0. We want from over here. Okay, so that's what I'm doing over here. Right, so I hope so like this thing makes some sense. Like I try my best to explain you each line of code what we are doing over here and why we are doing it like this. That's my main motive is. So please like this video, please guys. Okay, thank you very much. Okay, so now finally what I have to do, I have to return my before head dot next. Similarly, let me just take to my whiteboard. If you look at over here, I have to return after this one, not this one. This one is we just draw to save the list. Okay, this thing we just draw to save the list. Okay, so ladies and gentlemen, that's all the code is. Let me just run this code to see any compilation error do we face. So we will get through that. Okay, and here we go. We just get us something over here. Okay, it's my spelling mistake, BEFORE before head dot next. So spelling mistakes happen, so it's not a big deal. Engineers do a mistake, because that's why we are engineers. We do mistake, we solve the mistakes. So cheers to engineers. Okay, so let me just submit this code and I will tell you the space complexity and the time complexity. And let's see, it's accepting all the tests. And here we go, ladies and gentlemen. So it's going very well. Okay, so in this one, the time complexity is our big of n. Okay, because we are just traversing on the original linked list iteratively. Okay, we are traversing on our iteratively on our original linked list, because we are traversing number of nodes and n number of nodes. Okay, and the space complexity is our big of 1. Why? Because we are not using again any extra memory, no extra spaces. That's why I love linked list, because we are dealing with most of the time we are dealing with space complexity of big of 1. So thank you, ladies and gentlemen, for watching this video. I hope this thing makes some sense. If you still have any doubt, just do let me know in the comment section. If you still don't understand anything, I will suggest you to watch this video again, because you will definitely gonna understand. And thank you, ladies and gentlemen, for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Believe me, I love you. Take care, bye bye.